The methods demonstrated in this video show a convenient way to synthesize amino-terminated polysiloxanes and soft polysiloxane-based polyureas, which are suitable for the application as accommodating intraocular lens. The main advantage of these techniques is that synthesis and analysis of the polymers can be performed easily according to standard methods without any complicated experimental setup.
The implication of this technology extends toward cataract therapy, because most commercially available intraocular lens materials are based on acrylic polymers, which are too stiff to allow for a sufficient accommodation.
Although this method was optimized to provide materials of very soft characteristics of very high transparency, the method can easily be adopted to provide materials of completely different performance characteristics, materials that could also be applicable, for example, as coatings.
Visual demonstration of the methods is critical, as some of the synthesis and analysis steps are difficult to describe because they include experimental details that are important for successful performance.
First, add 19.5 grams of degassed D4 and 0.9 grams of APT-MDS to a 100 milliliter 3-neck round bottom flask equipped with a PTFE-coated centrifugal stirrer and a nitrogen inlet and outlet. Add approximately 26 milligrams of previously prepared catalyst and stir the reaction mixture for 30 minutes at 80 degrees Celsius under a continuous nitrogen flow. Using a dropping funnel,